So our second circular motion question is related to a plane. There's a plane here and it's doing a horizontal circle, so it's banked. And the question labels two forces on our plane. So we've got the weight here and we've got lift, but obviously lift, seeing as the plane is on a bank, of course lift isn't vertically upwards, it's at a slight angle. And the question, well, two parts. The first question is you need to explain how this lift maintains the plane in this horizontal circular motion. And so you need to talk about the two components of this force lift. And so the vertical component balances out the weight. Those two are equal and opposite, so the plane is staying horizontal. And the horizontal component of lift is the centripetal force that's going to maintain the circular motion. So those are the two forces. The vertical component counteracts the weight, and the horizontal component is what is the accelerating force that keeps it in a circular motion. Okay, so that's the first part, and then it gives you some details about the plane and asks you about the speed. So it tells you that the mass of the plane is 1.2 times 10 to the 5 kilograms. It tells you the radius of the circle is 2 kilometers, and it tells you that this centripetal force C is equal to 1.8 times 10 to the 6 newtons. And then it asks, what's the velocity? What speed does our plane need to be to maintain that constant circular motion? So the equation, I mean, it's a given equation, but really it's one that you should really know. Circular motion F equals mv squared over r. So we rearrange this to get the velocity by itself. So that's going to be F r over m. So the velocity is just going to be equal to the force, 1.8 times 10 to the 6 times by the radius, it's 2 kilometers, so that's 2,000 meters, divided by the mass, 1.2 times 10 to the 5 kilometers. Pop that into calculator and you find that the plane is doing just over 173 meters per second.